So, good afternoon. My name is Christopher Hierman. I'm here to talk about my organic chemistry project for organic chemistry. The first thing that I chose was my personal item. That was Crest toothpaste. The active ingredient in Crest toothpaste is stannous fluoride. The chemical formula for stannous fluoride is SNF2. Stannous fluoride has a molecular geometry of bent. The molecular geometry is due to fluorine being extremely electronegative, therefore it wants to be the greatest distance away from each other. Stannous fluoride works by preventing the excess amounts of calcium in saliva from crystallizing into tartar by acting as a solvent in which it dissolves the calcium, hence preventing the recrystallization of calcium. The stannous fluoride is the best fluoride used by dentists today because it forms a mineral protective layer over the dental tubules, which allows the decrease in sensitivity, prevents recrystallization of calcium by being a solvent, and has some antibacterial properties which assist in the prevention of dental diseases. There are no functional groups in stannous fluoride. The second item was the food item. The food item I chose was extra gum. The active ingredients in extra gum are sorbitol molecule, glycerol, and mannitol. These active ingredients play an important role in gum that most of us ignore. We will look at each of the ingredients below. The first ingredient is sorbitol molecule, which is a non-polar molecule. The sorbitol molecule is a sugar alcohol. This is actually what helps give gum its flavor. Sugar alcohols are used because they act as a sweetener, so they give extra sweetness to the gum. Now, some places will use additional alcohols, which is what Extra has done. They've added they have normally all gums have glycerol, but they've added the sorbitol molecule and the mannitol to it, and that gives it the longer flavor for the gum. The unique properties that most people don't understand about gum is that the sorbitol molecule and the glycerol alcohol actually help by fighting bad breath. They dissociate in saliva, which is 99.9% water, and are swallowed, and that's why the gum actually loses its flavor. However, the alcohol lyses bacteria in the oral cavity due to the water in the lipid bilayer, which is attracted to the alcohol. So it's kind of really unique on that side of it, and that's what helps stop bad breath. A very unique thing also to alcohols is the fact that bacteria cannot survive, or certain bacteria cannot survive in alcohol. So the old saying back in the day when they used to do different surgeries and stuff and pour, you saw them in the movies where they would pour the whiskey on a wound before they took out the bullet, it was actually really does help. Unfortunately, there's also yeast and stuff in that alcohol which is fermented, which is a bacteria which adds additional bacteria, so it's kind of unique as far as the bacteria capabilities. But chewing gum helps prevent certain dental bacteria, and also will help with certain other bacteria. So those are kind of the different things unique about the glycerol and the sorbitol molecule and mannitol. The last ingredient, or the last product that I chose was CLR. CLR has an active ingredient called laramine oxide. Laramine oxide is a polar molecule and has hydrogen bonding. The molecular formula is C14H32NO. The functional group is an amine that's inside of it, plus it has alkyd as well, or alkyl group. This is a good cleaning surface agent. The molecule cleans really well due to having a hydrophobic and hydrophilic part of the carbon chain. This is what helps by taking the water away, and also this is what helps to dissolve oils and stuff, or grease and stuff like that that's on your countertops. Laramine oxide requires extreme safety measures due to the absorbability through the skin, again in relation to the lipid bilayer of the cellular structure. The absorption is so great that in studies it has been seen in the kidneys, liver, gallbladder, and lungs. The chemical reacts with ions, which is why it works to remove rust and calcium deposits so well. So, in conclusion, our world consists of millions of non-organic and organic molecules reacting in infinite space and time. Life could not exist without chemical reactions. This homeostasis could not be achieved. It is truly amazing that we do things on a daily basis which involves organic and inorganic chemistry. This concludes my project for Organic Chemistry 1 2015. Thank you very much for your time, and I hope you have a wonderful day.